We now move on to the third module, which is about Darwin's grand idea, evolution through natural selection. But let's take up the story where we left off in the last module, with Darwin returning to England on the Beagle. So he returns after 5 years of travelling, observing, collecting, being desperately seasick. Here we see a rather nice portrait of the Beagle in port in 1841. It would go out again on another voyage, obviously not with Darwin on board. When he returns, all those ideas of him becoming a clergyman have dissipated. Nobody is talking about it anymore because very, very rapidly he builds some considerable renown within scientific circles. In fact, he meets Charles Lyell, the famous geologist, very early on, and they get on like a house on fire. And Lyell starts giving him all of these connections, integrating him into organisations like the Geological Society. He's building great connections, he's building a really good reputation. At the same time, his collections, which have been coming back to Britain in one form or another, on the Beagle or through other ships, are being passed out to other naturalists and botanists to analyse and explore and to try and describe. And the most important of these was Richard Owen, portrayed here. He was the preeminent British comparative anatomist of his day, and later on was to be regarded as a real opponent of Darwin's theory. And of course, Owen described some of the megafauna fossils, including Toxodon, which Darwin had found in South America. And Owen was able to examine it, reconstruct it, and then describe it as a new extinct species. 1 year later, in 1837, he opens a new secret notebook where he's jotting down his ideas. There are an incredibly large number of notebooks and notes that you can find online. He opens a secret notebook, and on the title page, he writes Zoonomia. Transmutation was on Darwin's agenda. Well, how do we know that transmutation was on Darwin's agenda? Just by the title, Zoonomia. Zoonomia was the title that his grandfather, Erasmus Darwin, had given to one of his evolutionary works. And obviously, with some degree of irony, Darwin himself adopts the title and indicates that he started thinking about speciation. He started questioning the idea that all species were fit and created by God at some time or another. The species transmutate or evolve. It's believed that he had a eureka moment. It's certainly something that Darwin himself claimed. A moment when he suddenly realised that species were not fixed, that species evolved. And it's very important that we understand this eureka moment because it feeds into a lot of the resistance that people had to Darwin's idea of natural selection. This is Darwin describing his eureka moment towards the end of his life in his memoir. He said that in October 1838, I happened to read for amusement Malthus on population, and being well prepared to appreciate the struggle for existence which everywhere goes on from long continued observation of the habits of animals and plants, it at once struck me that under these circumstances favourable variations would tend to be preserved and unfavourable ones to be destroyed. The result of this would be the formation of new species. Here, at last, I got a theory by which to work. Now, this is him looking back towards the end of his life at an event that had occurred some 40 years earlier. At the time, he wasn't really quite so articulate. This was what he scribbled in his notebook after reading The Principles of Population. One might say there is a force like 100,000 wedges trying to force every kind of adapted structure into the gaps in the economy of nature, or rather forming gaps by thrusting out weaker ones. The final cause of all the wedgings must be to sort out proper structure and adapt it to change. Somewhat different, I think you'd say, to the last quote. He's groping towards the idea of natural selection, having read Malthus. Well, what was Malthus's theory? What was Malthusianism? I have to say, it's one of the most important ideas that emerges out of the Enlightenment. It still has resonance to this day. Malthus himself, in his essay on the principle of population, was writing about humans and their relationship to the environment. And he was trying to demonstrate that there was no such thing as inevitable progress. We can see here on the graph the basic theory mapped out. What he believed was that human populations, grow geometrically or exponentially. We can see the growth on here. Whoop, up like that. That is, if they're unchecked. Food, however, the resources that support and help the population grow, only grow arithmetically along this line. And of course, where the population outstrips food, there is going to be a crisis. And here the point of crisis is famine and disease will force the population back. So rather than growing along that line, once it meets the crisis point, the population will dart back down that line before starting to grow back again. And Malthus, being a clergyman, had a series of ideas about how you might prevent these checks. Individual restraint, stop breeding basically, stop having sex, discourage the idle, make people emigrate to where there are more resources. These were all ideas that he put forward. Well, Darwin, reading this, thought about human populations, and then he thought about animal populations and thought, well, something similar seems to be going on in nature with species. And that was the starting point of him developing his ideas of natural selection. Now, as he developed his theory, he was drawn more and more towards what human beings did in their interventions in the animal realm. He noted that mankind uses selection to modify species of animals and plants. So you get fatter cattle, faster pigeons, woollier sheep. Selection is usually conscious and methodical, as this illustration of the improving landlord during the 18th century, Thomas Cook, Earl of Leicester, who used selective breeding to increase wool and meat yields. We can see as well the way that faster pigeons were bred by pigeon fanciers. We'll come on to pigeon fanciers on the next slide. Picking two fast pigeons, breeding them together to try and make even faster and stronger pigeons. And looking at this, Darwin wondered whether the same processes might operate in nature and how they would operate. Here we see him musing upon the selection of pigeons. And he uses as his example a particular variety of pigeon, the fantail. Here we see your common or garden pigeon. And what he says is, with a fantail, rather neatly pictured here, or a pouter, what an extraordinary looking pigeon, what had happened was that the pigeon breeder had seen, say, a pigeon with a fluffier tail and found another pigeon with a fluffier tail, mated them together to develop the fluffier tail and keep on doing that. And the same with the pouter and its neck. As he said, the man who first selected a pigeon with a slightly larger tail never dreamed what the descendants of that pigeon would become through long continued, partly unconscious and partly methodical selection. And the same would be true of the pouter. But what he also noted was release the things back into the wild, and very quickly they revert back to the type, the common or garden feral pigeon. Darwin took this theory and then applied it to nature, combining it with his Malthusianism. Here in this quote, he describes how nature might look all things bright and beautiful, as the hymn goes, but actually, when you look below the surface, it's nasty. It's what Tennyson called nature red in tooth and claw. All animals are striving for resources, competing with each other, particularly within one species. And we don't actually notice the extent of the destruction that goes on in nature. And it's this struggle for existence that specifically leads to the process of speciation It is, as Herbert Spencer would call it, the survival of the fittest. And as Darwin says at the end of this quote, it's the doctrine of Malthus applied with manifold force to the whole animal and vegetable kingdoms. For in this case, there can be no artificial increase of food and no prudential restraint from marriage. In other words, nature can't make those interventions that mankind is able to make. And then, this is the crucial thing. Individuals having any advantage, however slight, over others would have the best chance of surviving and of procreating their kind. On the other hand, we may feel sure that any variation in the least degree injurious would be rigidly destroyed. This preservation of favourable variations and the rejection of injurious variations I call natural selection. One of my favourite stories when I was young was the tale of the Fierce Bad Rabbit by Beatrix Potter, and for some reason this seems to tie into me with natural selection on very many different levels. This is a fierce bad rabbit. Look at his savage whiskers and his claws and his turned up tail. So variation is distributed randomly across the population of a given species. Some rabbits are stronger than other rabbits. These advantageous variations aid the struggle for life. So here we have the nice gentle rabbit. His mother has given him a carrot. He didn't go out and find it. His mother gave it to him. In times of scarcity, a resourceful or physically strong rabbit will outcompete a rabbit less well endowed. And here we see the fierce bad rabbit taking the carrot off the nice rabbit. He doesn't say please, he takes it. Now, a mechanism of heredity unspecified by Darwin allows for the favourable attributes to be passed on to subsequent generations. And it is the survivors anyway that are fittest. It's the survivors that breed. So resourceful, strong rabbits will beget resourceful rabbits. Now, this was the bit that Darwin may not have thought so much of. We know that variations interact with the environment, with land, resources, climate, ecology. We know that sometimes the grass is so green, the climate so mild, the resources so abundant that no matter how many predators or how many rabbits, the population will thrive, or as we might say, they'll breed like rabbits. But sometimes, in a time of shortage, only the fittest will survive. Here we see the fierce bad rabbit being something of a victim of genetic drift, which, as we'll see, is not something that Darwin himself thought about. In a time of shortage, the fittest will survive. Due to his accident with the shooting man, fierce bad rabbit has lost a lot of his advantages. His tail and his whiskers have gone. No doubt he won't survive the next shortage. So Darwin's speciation occurs when a geographical or environmental barrier divides the population of a species. The two populations diverge according to the different environments. Now, the important thing to do here is note that this ignores later versions of speciation that are propounded by population genetics, and we'll be looking at the emergence of population genetics and how it blends with Darwinism slightly later on in the subject. So Darwin didn't explore the hunter with his gun. He didn't explore the way that there might be small population overlaps or peripheral populations or any of the other issues that are part and parcel of the modern view of speciation. It was very much natural selection and, as we'll see slightly later on, sexual selection.